and gentlemen, this is Mr. Green, and this is a recording because on Monday the TOPS teachers are going to be having a little work day in which we're going to be working on some things, and I won't be able to make it to class. So I wanted to make certain I got this recording to you so that you would know what's going on this week. First things first, I wanted to make certain that I let you all know I appreciate if you've been sending me your course information every time you talk to me. Send me K-mails, things like that. It really helps Mr. Green. He's getting older and he can't really remember sometimes what course you're in. So if you tell him what course you're in, it really helps him find your information a little bit quicker and therefore respond to your questions a little bit faster. What I'd like to do today is cover a couple of topics that are at the end of Unit 4 and or the unit that we're on, Unit 3, and then go into a review of Unit 3 before we go on. Okay? So the first things I want to make certain I cover is this concept of a mid-segment. Mid-segment is a line on a trapezoid that goes from the midpoint of one side of the trapezoid to the midpoint on the other side of the trapezoid. See, midpoint, midpoint, middle point on both sides of these trapezoids. And we're going to connect those two with a straight line going across there. Okay? Line going across like that. This line that's in red right here would be the mid-segment. Now there's a formula for the length of this mid-segment. If I take the bases, the ones that are parallel to each other, BC here, see how it's marked as being parallel to the AD down here, this base. These two bases, if I take them and add their lengths together and divide by 2, I will get the length of the mid-segment. So it's 1/2 of BC plus AD. That's what this says right here. BC plus AD divided by 2 is equal to EF. And these are easy little equations to solve, but there's some trickiness to them, so I want to make certain I work several of them to show you how they're done. Okay? In this first one here, I've got 12 as a base, and I've got 8 as a base. So I'm going to add 8 plus 12 divided by 2, that's equal to 20 divided by 2, which is equal to 10. That means that this mid-segment is 10 units long. It's real easy for you to just add those together and get that base. Okay? Here's where we start adding some complications to it. When I start looking at it and putting equations or expressions in here, oh, Mr. Green, that's going to make it difficult. Not really. I'm going to do the same thing. 21 plus 27 divided by 2 is equal to 5x minus 1. Well, 21 plus 27 is 48. Yeah, 48 divided by 2 is equal to 5x minus 1. So when I divide by 2, I'm going to get 24 is equal to 5x minus 1. Add 1 to both sides of that equation, and I get 25 is equal to 5x, or x is equal to 5. No problem there. I'd already figured out that this base here was 24. How'd I get that? Well, right here, 21 plus 27 is 48 divided by 2, which is 24, right? So if I stick the 5 in there, 5 times 5 is 25, minus 1 is 24. Yay, it worked out. Okay? So let's look at another one. This one, a little bit more difficult. So what do we got? We've got an expression up here at the top and an expression down here at the bottom. Let's do the same thing as we did before. We're going to say x plus 3 plus 4x plus 7 divided by 2 is equal to 15. So when I combine my like terms here, I got an x plus a 4x, that's a 5x, plus 3 plus 7 is 10. And I'm going to put that in parentheses. Divided by 2 is equal to 15. Well, you know what? 5x is not going to divide by 2 very nicely. So I'm going to multiply both sides of my equation here by 2. Why? Because then these 2's cancel out, and I'm left with 5x plus 10 is equal to 30. I can subtract the 10 from both sides of this equation and get 5x is equal to 20, or 20, thank you, or x is equal to 4. Now I can use this 4 and stick it into both equations. 4 times 4 is 16 plus 7, right? So 16 plus 7 is 23, right? And I can stick 4 up here. 4 plus 3 is 7. So I've got 23 and 7. That's 30 divided by 2 is 50. Yep, checked out just fine. That would be my answer that I would have right there. Okay? So let's look at one more here. Okay, what if we had something like this, where they gave me two expressions, but they're not on the basis? I'm going to do the same thing. I'm not going to change what I'm doing here. 2x plus 6 plus 30, parentheses around that whole thing, divided by 2 will be equal to 3x plus 4. 3x plus 4. It kind of went off the screen there a little bit. Okay, so I'm going to combine my like terms, and I'm going to get that 2x plus 36 divided by 2 is equal to 3x plus 4. Where did the 3x plus 4 come from? Right here. It's the mid segment, right? And I'm taking these two here, adding them together to get the numerator here, right? Now, since these two are both even, 2x and 36, I'm going to go ahead and divide them by 2, and I'll get that x plus 18 is equal to 3x plus 4. And I can subtract an x from both sides and subtract a 4 from both sides, and I get 14 is equal to 2x, or x is equal to 7. Woohoo, I now know what x is. I can come back up here, and 2 times 7 is 14 plus 6 is 20. Okay, and 3 times 7 is 21 plus 4 is 25. Well, 20 plus 30 is 50 divided by 2 is 25. Check, that worked very well. So I found that x was equal to 7, and I found both of the missing links that I was missing here. Okay? Now, in the book and in the lessons, they take great care in telling you about the mid-segment theorem and then telling you about the triangle mid-segment theorem. Essentially, they're the same thing. If you consider that in the triangle mid-segment theorem, the length of this distance up here is 0. So I could still add 0 plus 18. 0 plus 18 is 18. 18 divided by 2 is 9. So that one would equal 9. 18 plus 0 divided by 2 is equal to 9 divided by 1, which is equal to the mid-segment x. So 9 equal x is my answer. Okay? Or the mid-segment there. So nifty way of only having to remember one theorem to get both situations taken care of. In this situation, they didn't put something there, but essentially what we could say is that this down here is x, or the line segment UL. Wouldn't make any difference here. And I could say x plus 0 over 2 equals 32, right? Well, that's x over 2 is equal to 32. X is equal to 64. Why did I do that? I multiplied both sides by 2 to get rid of that 2 there, and I'd get x is equal to 64. So that means this distance here is 64. It's twice as long on the base as the mid-segment. Easy enough to remember. Here we've got 58 and 5x minus 1, right? So I could say 58 divided by 2 will be equal to 5x minus 1. Add 58 divided by 2 is 29 equals 5x minus 1. I add 1 to both sides of this equation. I get 30 is equal to 5x, and x is equal to 6. So 5 times 6 is 30, minus 1 is 29. 29, and 29 times 2 is 58. So check. That worked out, and that would be the answer that I'd be looking for. Okay? Pretty straightforward. Okay, couple more here. Looking at this one, if I've got 0 up here, and 34. So that's 34 divided by 2 will be equal to 3x minus 1. Well, that's 17 is equal to 3x minus 1. Add 1 to both sides of the equation. I get 18 is equal to 3x, or x is equal to 6. I know that this is going to equal 17 in here, but 3 times 6 is 18 minus 1 is 17. Ta-da. Check. That'd be my answer. Okay. One more here I want to work for you. What if they gave you expressions at both ends of this? So I've got 8x minus 2, 8x minus 2 plus the 0 at this end, divided by 2 will be equal to 2x plus 1. Well, 2 goes into both of those fine, so 4x minus 1 is equal to 2x plus 1. Subtract the 2x from both sides of the equation. Add the 1 to both sides of the equation, and I get 2x equals 2, or x equals 1. So 2 times 1 is 2, plus 1 is 3. 8 times 1 is 8, minus 2 is 6. So I found the base is 6, the mid segment is 3, 1/2 of the base. Yep, yeah, that checked out just fine. So I would say x equals 1 would be my answer. Okay? Now I want you to notice over here on the side, these are mid segments. That means their two parts there are equal. So you could say 3z equals z plus 22, and subtract a z from both sides, and I would get that 2z is equal to 22, or z is equal to 11. So this is 33, and this one is 33. And so the two segments here are equal in length. Cool? That's the way you have to do these type of problems. Remember, these sides are going to be equal on this situation. And these sides over here are going to be equal to each other on this situation. But they're not equal going across. They're only equal on that side. Okay? The other topic I want to talk a little bit about is slope. Slope is how much something rises divided by how much it runs. Well, that's not a very good answer to most people. It's how far it goes up based upon how far it goes right or left. Okay, well that makes a little bit more sense. Slope is always positive when it's going up on the right, and it's always negative when it's going down on the right hand side. So if it's going up on the right hand side, it's a positive number. The way I like to think of it is the change in the y's divided by the change in the x's. Okay? And they're going to use these little delta signs or little triangles there. They're called deltas. It's a Greek symbol for change. And I'm going to say the change in y's. Well, where are the y's? Well, here are the points. There's a 5 and a 2 that are my y values. So 5 minus 2 is 3. Okay, I got that. And then I've got x values here. And my x values are 2 and 1. So 2 minus 1 is 1. Okay, so I've got 3 divided by 1. My slope would be 3 divided by 1, or 3. And it's a positive number because it's going up on the right. So it's exactly what I thought it was going to be. Okay? Or at least in the range that I thought it was going to be at. You notice how this one's going down on the right? I'm expecting this to be a negative number, aren't I? So let's see if that's what we get when we do this. I'm going to find my change in my y values. So that's going to be 3 minus 1. Where did I get that? The 3 came from right there, and the 1 came from right there. 3 minus 1 is equal to 2. And then I'm going to find my change in my x values, and I'm going to take the same values here, or the same points, and I'm going to put them in the same order. So 0 minus 4. Going off my little sled here. 0 minus 4. Well, that's equal to a negative 4. So my slope is going to be equal to 2 divided by negative 4. Well, that's equal to 1 over 2, but it's a negative slope. And that negative sign doesn't matter if it's on top, bottom, or just in front. It would be a negative slope. And that's exactly what we expected. Down on the right. See how it's pointing down on the right-hand side here? Where is my pen? There it is. Down on the right-hand side, it's going this way. So that's why I'm going to say it's going to be a negative slope. Negative 1/2 would be my answer there. Okay? Couple more to see what we can come up with. I hope everyone looked at this one and immediately thought, down on the right, that means it's going to be a negative slope. And you started looking for some points. Well, there's one point right there where this line goes through, and there's another point right there where it goes through. Well, it's now a matter of identifying those points. And this one is at negative 1, 1. And this one down here is at 0, negative 1. So I'm now going to find my change in my y values. So I'm going to say 1 minus a negative 1, and I'm going to get a 2. I'm going to look at my change in my x values, and I'm going to say it's a negative 1 minus 0, which is a negative 1. And my slope was going to be my change in y's divided by my change in x's, and that's going to be equal to negative 2 over 1, or negative 2. Cool? Let's look at one more here. If I'm looking at that point right there, it's got a point right here. Where's my mouse? There it is. There it is. Okay, it's got a point right here of 2, negative 3. And it's got a point up here of 4, 0. So all I got to do, find my change in y's. I'm going to say 0 minus a negative 3 is going to be a positive 3. My change in my x values is going to be 4 minus 2, which is going to be a 2. And my slope, m, is going to be my change in y's divided by my change in x's, which is going to be equal to 3 over 2. That means it goes up 3 and over 2. That's what it does. It goes up 3. 1, 2, 3, and over 2. 1, 2. Very good. So that's how we do that. Now, I hope everyone looked at this and saw that it went up on the right. It was a positive slope, and that's what we got, positive slope. And so that's what I'm going to think my answer is correct. Now, the other thing I wanted to do today before I got away from here was to give you a quick review over Unit 3. Okay? So this is not a long review, just so it's a quick one so that we make certain we get all the topics covered here. If I'm looking at this object right here, I see 4 sides that are marked being the same length. Okay? I see 4 sides, so it's a quadrilateral, right? So it's an equal lateral quadrilateral. And if I've got an equilateral quadrilateral, I have got a rhombus. Okay? So this is a rhombus. Cool? Now, if a rhombus has equal angles on every corner, then you can say the rhombus is a square. But that's not true in this situation, so we do not have a square. We have a rhombus. And look, all I got to do is lengthen this out a little bit. Now they're all equal, and I've got 90-degree angles. So there, that would be a square. But if it's like this, it is a rhombus. Okay? Going on. Just as a point of reference, how many sides are on a hexagon? 6. How many sides are on a heptagon? Hepta, 7. How many are on a decagon? 10. Easy enough to do. Here I've got a triangle. The only thing they're telling me in this triangle is that this angle up here is 120 degrees. They're not telling me anything else. I cannot read into this and add anything to it. All I would be able to say is that it is an obtuse, scalene triangle. Okay? And I might even leave the word scalene off because I don't know anything for sure. Okay? The only thing I do know is that this angle is more than 90 degrees. That makes it an obtuse triangle. Okay? Rhombus properties. Lots of properties to try to memorize here. Okay? Rhombus is a quadrilateral, so it's a quad with equal sides. Equal sides. Okay? It has diagonals that bisect, perpendicular, and that also bisect angles. So they bisect each other, they're perpendicular to each other, and they bisect the angles in the corners. Okay? It's got two sets of equal angles opposite. So opposite equal angles. Cool? A lot of things. You can imagine that since I'm pointing this out as a rhombus, you can bet you're going to have a question about a rhombus. Okay. Now on this slide, let's see here. Just a second while I do this. Yeah, I had to put it in there a couple more times. Okay, so if I'm looking at this slide right here, what I see are parallel lines with a transversal. So what we're looking for are corresponding angles. Corresponding angles are going to be on the same side of the transversal, and one is going to be outside and another one is going to be inside. So these are considered corresponding angles, 1 and 5. 3 is inside and its corresponding angle is 7 outside. Okay? 2 is inside and 2 is outside and 6 is inside. Corresponding angles. Okay? 4 is inside and 8 is outside. Corresponding angles. I've tried to color code them here so that you can tell which ones are corresponding angles. Okay? If I'm looking at this and I'm looking for alternate interior angles, alternate interior angles are going to be inside of the parallel lines, inside, that's where that interior comes from, and on alternate sides of the transversal. So these two would be the ones that would be alternate interior angles, 3 and 6. There'd be another pair of alternate interior angles. It would be these two over here, which would be 4 and 5. Those would be alternate interior angles. Now, if I'm looking for alternate exterior angles, okay, well, those would be the ones that would start out outside of the parallel lines, and they're on alternate sides of the transversal. So 1 and 8 would be alternate exterior angles. Okay? And 2 and 7 would be alternate exterior angles. They're exterior, outside of the parallel lines, and on alternate sides of the transversal. And all three of these, the corresponding angles, the alternate interior angles, the alternate exterior angles, are all congruent pairs of angles. That means the two angles are congruent to each other. One final set would be the same side interior angles. And in this situation, we're looking at something a little bit different. We're looking at angles 3 and angle 5. And these two angles are not equal to each other. So you would say the measure of angle 3 plus the measure of angle 5 equals 180 degrees. And I want you to see how I'm getting this. They're on the same side of the transversal. Transversal is the line that cuts across here like this. Okay? They're on the same side of it, and they're interior to the angles, to the parallel lines. And from the same perspective, angles 4 and angle 6 would be same side interior angles. And you would say the measure of angle 4 plus the measure of angle 6 would equal 180 degrees. Cool? Okay. When you see a picture like this and it says, describe this shape, it's not asking you to say that it's a Star of David. Okay, yes, that is a name for this shape. But they're wanting the mathematical definition for this one, and it's going to be a concave. Where did the word concave come from? It caves in. It's not convex where it goes out. It's concave. It is a 12-sided, so that's a duo, D-E-U-O, decimal, deca, polygon. Duodecadecimal polygon. Duodecapolygon. Okay? And all you got to remember, concave are innies, convex are outies. Okay. Let's see here. This one, interior angles. How do you find interior angles of a polygon? Well, the interior angles of a polygon are the angles, you count the number of sides. So you find the number of sides. Okay, you take the number of sides, you subtract 2 from it. Now I can't find my mouse. There it is. Okay, minus 2, and you take that value and you multiply it times 180. So the number of sides minus 2 times 180. So if I've got a pentagon, well, that's 5 sides. So I'm going to say 5 minus 2 times 180. Well, that's 3 times 180. That's 300 and 240. That's 540 degrees. Okay? So that's the sum of the interior angles. So if you're looking at the pentagon, the one that is in Washington, D.C., and you want to know how much each one of the angles are at the sides, it is considered to be a regular pentagon. That means all of the angles are congruent to each other. So if I know the sum is 540, I take 540, divide it by 5, and I get 108 degrees at each corner. Okay? If it's not a regular polygon in which the angles are not necessarily equal to each other, but you would have different angle measurements in there, you could add those numbers up and make certain it equals 540 and solve for any variables that you might have. Okay? So, looking at the mid-segment, one more time about mid-segment here. If I've got a triangle from this point right here to this point right here, it would be considered the mid-segment, going across like this. The length of this mid-segment is 1/2 of this base down here. Okay? This portion is equal to this portion. This portion is equal to this portion. It's real easy to solve these things and get answers for them. Okay? If we're talking slope and midpoint, then to find the slope, you take the change in the y's divided by the change in the x's. Well, the change in the y's in this situation is going to be 7 minus a negative 2, which is equal to a 9, divided by negative 3 minus 5, which is a negative 8. And so my slope is going to be equal to 9 over negative 8. That's my slope. My midpoint, it's a point. So I'm going to take my x values, negative 3 plus 5, and I'm going to take that and divide it by 2. And my y value, which is going to be 7 minus 2, 7 plus a negative 2, divided by 2. And that's negative 3 plus 5 is a 2 divided by 2. And a 7 minus 2 is a 5 divided by 2. That's a 7 minus 2 is a 5 over 2. And so my midpoint is going to be at 1 comma 2.5. Okay? A few more slides here. If I have vertices at these points at A, B, and C, and I'm asking, is it a right triangle? Well, there's a couple things you can do here. One, you could try to graph them out. Okay? If you graph these out, what you're going to notice is that these two are going to be straight up and down. One of them is up at 6 and the other one's down at negative 4. And this one here is over at 4, 4, at negative 4, 4. So it's down here at negative 4, which is at the same point here, but over at 4. So it's like this. And so you would be able to say, graphically, I can see that this is a right triangle. But the way you're supposed to do this is to find the slopes. The slope of AB would be equal to 0 minus 4 divided by 6 minus a negative 4, which is going to be equal to negative 4 over 10, or negative 2 over 5. Well, that's going to be this slide right here, isn't it? Negative 2 over 5. We got that. And my slope of BC is going to be equal to 0 minus 0. Well, I don't even need to figure out what the bottom is here. That's going to have a slope of 0. That's A. This one's A down here. This one's B up here. So BC is this horizontal, or this vertical line right here. That's a vertical line. And my slope of CA, which is going to be C is 0 minus 4 divided by negative 4 minus a negative 4. And that's going to be equal to negative 4 over 0. Well, that's undefined. And that's this horizontal line right here. Okay? Not right. This one's got to be B. Nope, that one's B. This one's got to be C. Okay. Yeah. So this one's undefined. This one's 0. Okay. Couple more things here in this unit. One of them we talked about symmetry. Symmetry is where I can take something and divide it in half and it folds and lands right on top of itself. Okay? So if I'm looking at these three lines right here and I was trying to decide if this had symmetry, I would have to try to take a line and draw from one point to the opposite side and see if that divided it in half. That would not divide this one in half. So I would not use that as a line of symmetry. Okay? If I took a line and drew it from the midpoint here to this side over here, it doesn't look like that divides it in half either. Okay? And it's a visual thing. Can I do it, take a line like that and divide it and get something that divides the object in half so that the other corners will match up? Okay? I am not seeing a line of symmetry that would work for this particular object, A, B, or C. A, B, C. Okay? But it is a matter of just dividing the object in half. Remember, when we're talking about lines of symmetry, if you're talking about a regular object, It has the same number of lines of symmetry, SYMMETRY, as sides. Okay? It also has a degree of rotation. Equal to 360 divided by number of sides. And it's really easy to figure these things out. So if I'm looking at a square is a regular quadrilateral. That means it has 4 lines of symmetry. And it takes 360 divided by 4, or 90 degrees of rotation, to make it line up on top of itself. Okay? So for the part 2, I'm thinking there's either 3 or 5 problems depending upon what course you're in. First one is going to be to find the number of lines of symmetry and the degree of a regular polygon. I just told you how to find it. It's real simple. Okay? One of them is going to be to find the mid-segment length, and you got to show your work. You will have both triangle and trapezoid, so look at it very carefully. And one of them is going to be, given some points, find out what kind of a quadrilateral the object is. Do this by finding the slopes. If you don't find the slopes, you will not know if the sides are parallel to each other or perpendicular to each other. Okay? If you find the slopes, 2 parallel lines have equal slopes. Perpendicular lines have slopes that multiply to give you -1. Okay? There will be a proof on some of them, on some of the classes. I think it's the honors class in 203. Just look at the theorems that we used in this unit. They're in the back of the book. Make certain you use them. You will use them in the proof. Okay? Exterior angles. Don't get fooled and try to find the interior angles when I'm looking for the exterior angles. I'm going to give you equations for the interior angles, and you're going to go, well, how do I use that to find the exterior angles? You find the interior angles first. You subtract them from 180, and that gives you the measure of the exterior angles. It will not be that difficult, but just don't get confused as to what you're looking for. Okay? So my secret word for today is wish, W-I-S-H. And you'll find the exit quiz along with this recording in your announcements that I'm sending you on Sunday. So if you can't find it, look in your inbox and read the thing I'm sending you for Sunday. Okay. Talk to you later. Bye.